So hello, everybody. Thank you so much for joining me today. Today, we're going to be talking about an anti-cancer lifestyle and how to heal cancer and prevent cancer with your immune system. And so it's all about lifestyle. The first half of this talk will concentrate on your lifestyle and what you can do to strengthen your immune system against cancer. And the second portion of the talk will talk about how to actually continue and boosting your immune system with something called regenerative medicine and increasing your immune cells to fight against cancer. So I'm so pleased that everyone was able to join today. Just a little bit about me. My name is Minako Abe. I am a board certified medical doctor in the US in both emergency medicine and in lifestyle medicine. And currently I am the vice president of the Tokyo Cancer Clinic, where we provide regenerative medicine. So it seems like a big jump from emergency medicine to doing what I do now. And I practiced in New York City for over 15 years, and I loved working in the ER and seeing patients in the ER. So it was wonderful, except for I noticed that about 80% of my patients were actually coming in for things that were potentially preventable. So whether that was, for trauma or infections or heart disease or even cancer, right? Cancer has been shown to be 30 to 50% preventable. So I really got interested in lifestyle medicine because we need to start thinking, further upstream. What can we do to strengthen our bodies to prevent things? And how do we create an environment in our bodies to really be able to efficiently fight against certain illnesses? So that's what I do now. And 8 years ago, I was blessed to be able to return back to Japan, where I grew up, and I brought my family here. I encountered a very personal sort of scare and medical experience after I returned to Japan. And about a year after we came here, my husband was diagnosed with a very rare spinal cord tumor. So rare that in the literature, I think there were only 7 cases that I found. So I panicked and I thought, okay, what do I need to do now? Okay, so I contacted my colleagues in the United States and I said, okay, where should I bring him? Where can he get the best care? And to my surprise, all the neurosurgeons there said, no, stay exactly where you are. Because in Japan, there are many, many therapies that are not available elsewhere in the world. And the technology and the treatments here, can be really fantastic. So, even I didn't know this, but we ended up staying here and we got fantastic care. And, happily, my husband recovered fully and he's doing great. So I'm really passionate about bringing this information to anyone who is willing to listen that, we do have some fantastic treatments. So we want to all know our best options. So that's why I am here with you today. So just getting into our talk, right? If you are here today, cancer is probably either, in your family or, you might be going through it now, you might be recovering from cancer yourself, right? And it's no wonder because 1 in 2 men and 1 in 3 women will end up having cancer within their lifetimes, right? And this number is actually increasing. It's not getting better. And people who are getting cancer much younger and younger these days, right? And you think, well, how is that possible, right? Because isn't cancer genetic? Well, only 5 to 10% of cancers are actually inherited, right? With like BRCA genes and things like that. And they found that 30 to 50% of cancers are actually preventable. And the rest of the half, right, are probably influenced by things like toxins, infections, inflammation, how we live our life, our lifestyle, and sometimes it's just bad luck. So if you think about it, right, we humans, we're just made up of trillions of cells, right? And these cells, we don't keep the same exact ones that we're born with. As we grow, our cells divide. And as we age, all of our cells have this lifetime turnover. So, and as each of our cells turn over and the old ones are replaced by new ones, we're kind of bombarded by all these different things, right? Whether it's UV radiation, whether it's pollution, viruses and bacteria, inflammation, alcohol and tobacco. All of these things, influence our cells, right? Whether it's like the types of foods that we eat, right? Ultra processed foods, and even obesity. In the United States, 40% of cancers attributed to actual obesity. So many of us may actually have genetic predispositions, right? The cancer genes, right? And as each one of our cells are turning over and going from old cells becoming new cells, mistakes can occur. So much that they say that 5,000 genetic and epigenetic changes occur in our cells with the potential to turn into cancer every single day. Okay. So, why don't we all have cancer? Well, in a way, we probably all do have cancer, right? We all have cells in our body that have undergo mistakes, right, and become abnormal or precancerous or cancerous, right? But the reason why we don't all end up with big massive cancers is because our immune system can detect these abnormal cells and get rid of them when they're all at the small stage, right? So cancer is really a result of these rogue cells starting to grow and grow and grow out of control and escaping our immune system, its ability to get rid of these abnormal abnormal cells, right? And by the time we can detect that there is a cancer going on in our bodies, right? We already have 100 million cells present. So, a 1 centimeter cancer that's detectable by CT or PET CT, right? We already have 100 million cells that are present. So we really want to try and get rid of the cancers in our bodies at this early stage, which is why it's so important to make sure that our immune systems are, staying into top shape. So, our immune system is fantastic in that it can recognize and attack any invader, whether these invaders are viruses or bacteria that are infecting our cells, or whether it's cancer. Our immune cells detect cancer cells as these foreign invaders. And some of the big players in our immune system, and I'll go through some of this later on, but we have a cell, a very special cell called the DC or dendritic cell. And the dendritic cell has the ability to recognize that these are abnormal cells, that these are cancer cells. And it has the ability to take in that information and to transmit it to the rest of our immune cell army. So our B cells, our T cells, our natural killer cells, the dendritic cells actually go and talks to these other immune cells and says, okay, these are the targets. These are the cells that you need to go seek out and find and destroy. Okay. Not only that, right? Our dendritic cells and our immune cell has the ability to create something called a memory cell. So our memory cells remember that these are the foreign invaders. And so if it encounters it again, then it remembers and can call up our immune cell army to go back and attack it. So that's how vaccines work, right? If you think about it, like if you've gotten the COVID vaccine, we get injected with an antigen, right? And our immune cell takes that in and it tells our immune cells, you might mount a little bit of a feverish response in reaction to that vaccine. But then it creates these memory cells so that you have more of a long-term ability to fight against this invader should it come back again. So again, our immune system is so important. And, problems really arise when our immune system kind of fails us and cancer cells go around, evade detection, grow and grow and grow and divide out of control. So, okay, so that's where our lifestyle comes into play, right? So, whether it's cancer or heart disease or diabetes or Alzheimer's, right? People are like, oh, well, it's genetic, it runs in my family. Yes, that might be true. But whether or not these genes are expressed has a lot to do with our lifestyle, right? We all know that tobacco and alcohol, too much of that can make us predisposed to cancer, right? But in just the same way, the root cause of disease is really caused by a lot of things, like including our nutrition, how we eat, how we sleep, how much we move, and how we handle our stress. Like all of these things take into play in determining whether or not these favorable genes or unfavorable genes are expressed. So that's why you can have two identically identical twins. They have the same genes, right? And one might get cancer and one might not. One might get cardiovascular disease and one might not. It's because all of these things take into play. Now, I'm not saying it's your fault at all, right? Because you can have the perfect lifestyle. You can do all the right things and still get cancer. And you can do all the wrong things and drink and smoke all your life and not get cancer, right? So this really is not the whole picture, but it has a lot to do with whether or not these genes are expressed and why you get these diseases, and really setting yourself up in terms of risk, right? Obviously, your risk will be much lower if you do all the right things. And you're giving your body, better chance. Some of these things are just bad luck, but I feel like if we control what we can, we can't control the things that we can't, but for the things that we can control, we can do our best to try and set up a good environment for our bodies and ourselves. So the way I like to think of lifestyle is, 4 major pillars: how we eat, how we sleep, how we move, and how we handle our stress, how we relax. So from this view, I'm going to go through each of these 4 things and how we can set up a healthy immune system that's able to fight against cancer. So starting with eat, right? The number one thing you can do is to unprocess your food, right? You want to eat things that look like food, like that your great grandparents would recognize and say, okay, yeah, that looks like food, and not some strange ultra processed food, right? That they would not necessarily recognize as food. And the reason for that, right? We found that if you increased the ultra processed food in your diet with a 10% increase in processed foods, this leads to a 12% increase in your cancer. So, why is this, right? Well, processed foods, they were invented for a long shelf life. So in doing so, they take out a lot of the natural phytonutrients, they strip out the fiber, they strip out a lot of the vitamins and minerals, so it lasts a long time in the shelf, and it's convenient. But in doing so, we're taking out all of these healthy nutrients, the vitamins and minerals and fiber that we need for, to nourish our bodies and to nourish our immune systems. So that's number one. And, I mentioned fiber, right? Why is fiber so important? Well, it helps with our digestive system, but fiber itself is not a micronutrient. We can't eat fiber and digest and gain energy from the fiber. So it's not really for us, but it's for our gut bacteria. Our gut microbiome feeds on the various fibers and thrives, right? And our gut microbiome is intricately associated with our immune system. 70% of our immune system is actually in our gut microbiome. And it's found that the gut microbes that we have actually influences whether or not we respond to cancer therapy, specifically cancer immunotherapy. So we can actually check our gut microbiome. And if you don't have like Akkermansia muciniphila, or if you don't have bifidus bacteria in your gut, your likelihood of responding to these therapies go way, way down. So it's really important to have particularly, the quote, healthy bacteria in your gut, but it's also important to just have lots of species diversity in our gut. And the way to get a healthy immune system and a healthy species microbiome is to increase the fiber and the polyphenols from a variety of plants. And that will encourage a favorable microbiome for a healthy immune system. So what are some of these healthy foods, right? These are my top 4 cancer fighting foods that I like to talk about. And number 1 is the cruciferous vegetables, right? So these are your cabbages, your broccoli, your cauliflower, your Brussels sprouts. So these types of foods, the cruciferous vegetables, they have something called sulforaphane in it. And sulforaphane is a compound that actually directly prevents the development and the progression of cancer. So as much of these vegetables that you can get, the better. Number 2 is stone fruits. So these stone fruits are apples, pears, plums, peaches, nectarines, like these fruits that have that stone inside of it. So these stone fruits actually, they inhibit a hormone called VEGF. VEGF stands for vascular endothelial growth factor. So in order for tumors to grow from being like a microscopic 1 millimeter tumor to growing to a large tumor, what it does is it releases the VEGF hormone to attract blood vessels to form and go to the tumor, right? And these stone fruits actually have a hormone that blocks this VEGF so that it hopefully lowers the attraction of blood vessels to come and grow and feed the tumor. So that's number 2. Number 3 are berries. You know, all these deep purples, red, these colors in these berries, right, have polyphenols in it. And polyphenols are antioxidants, they're anti-inflammatory, and they encourage something called cell cycle arrest. So as your cells are turning over and old ones are turning into new ones, or you're growing multiple cancer cells, right? These polyphenols actually help to stop this cell cycle arrest and helps your abnormal or cancerous cells go into something called apoptosis or programmed cell death. So that's why berries are good for you. And number 4 are the alliums. So the alliums are the garlics, the onions, the leeks, the shallots, these types of foods. Like, you know how when you're chopping up an onion, you have that, you know, your eyes start to tear and water, right? That stinging sensation. And that is from something called organosulfurs, right? These compounds, they actually help to inhibit cell mutations, and it inhibits cell growth. So these are my top 4 cancer fighting foods that I like. And then the top 4 foods to limit. So what foods should we not be eating? So number 1, I talked about the ultra processed foods, right? It has all the good nutrients sort of stripped out of it, and has lots of sugar, and they fill it with a lot of salt, fat, and sugar, right? To make it very hyper palatable. It actually, they're designed to make you want to eat more of them, right? They're almost addicting. But it doesn't have the fiber that you need, and it doesn't have any of the good beneficial nutrients that you need. Number 2 are the processed meats and the red meats. So the processed meats are things like bacon, sausage, salamis, you know, hams. They taste very good, but they have a lot of compounds in it that are actually known carcinogens. And that's the same with red meat, right? The red meat has been associated, especially with colorectal cancer. And it's not like you can't ever eat these foods, but the recommendation is for the processed meats to really eat them as little as possible. And with the red meat, they say eat less than 500 grams of red meat per week, which is still quite a lot, actually, if you think about it, right? Because 100 grams of red meat is about the size of the palm of your hand or a deck of cards. And that 5 times a week, I think a lot of people normally eat less than that. So that is the recommendation in terms of red meat. Number 3 are the sugar sweetened beverages. So a lot of these sweetened drinks, I'm sure you've heard that, you know, sugar feeds cancer. So you want to minimize, you know, the sugar that you eat. You know, all of our cells use sugar or glucose for energy, right? But cancer cells, they like to preferentially suck up all the glucose that you can, which is why that when you go for a PET scan, right, what they do is they take radioactively labeled glucose, that's sugar, and they put it in an IV, and they let that circulate in your body, and then you take the CAT scan, a PET scan of what cells are preferentially sucking up all that glucose, right? And what lights up is what's lighting up is where your cancers are starting to increase their metabolism of glucose. And so that's where that idea comes from, that, you know, glucose feeds sugar. But not just that, what happens when you have a lot of sugar, and especially with sugar sweetened drinks, right? It spikes, you know, it's easily absorbed into your bloodstream. So your glucose rises, and with that rises insulin. So insulin and insulin-like growth factor, they really rise in response to high glucose in your bloodstream. And those are very powerful growth promoters of cancer. So that's why you want to try and limit and keep your insulin levels down and keep your glucose levels down. And that's also why if you have type 2 diabetes, that means your blood glucose levels are generally kind of higher and your insulin levels are even higher. You have insulin resistance. And that's why people with type 2 diabetes actually have a 30% higher risk of also getting cancer. So that's sugar sweetened drinks. And then alcohol, right? Alcohol is a tough one. Lots of people like their alcohol and people are like, well, isn't red wine good for you, right? And yes, red wine out of all the alcohols is probably the best choice because it does contain the dark red polyphenols. And that part of it is good for you. But alcohol itself, when we drink alcohol, we convert it into something called acetaldehyde. And that is actually a known carcinogen, which is why the more you drink, the higher your risk of especially oropharyngeal cancers, esophageal cancer, stomach cancer, pancreatic cancer, liver cancer, colorectal cancer, even breast cancer is associated with high intake of alcohol. So the current recommendation with alcohol is that if you're not a drinker, there's no need to start, right? You're not going to get that much more polyphenols just from drinking red wine. You can get that from other foods. But if you are a drinker, you want to try and limit your alcohol. And right now, the recommendation is for men to drink 2 or less drinks per day. And for women, it's 1 or less drinks per day. And that's just in general because men have larger bodies than women. And, if you are actively combating cancer right now, I would say definitely try and stick to about 5 drinks a week. And you can't wait until the weekend and just say, okay, well, I'm going to save my 5 drinks and I'm going to drink that, on the weekend, because when you do that, you're still metabolizing a large amount of alcohol and the amount of acetaldehyde actually goes up, right? And particularly if you're of Asian descent, we tend to have the gene where you drink alcohol and then you turn bright red. And that is an indication that you have higher levels of acetaldehyde in your bloodstream. So especially if you're the type that drinks alcohol and you turn bright red, you want to try and minimize your alcohol intake. So, okay. And I will get to the questions in the chat sort of at the very end. So go ahead and type in your questions and I will get to them in the end. Okay, so that was food, okay, how we eat to improve our immune system and to fight against cancer. Number 2 is sleep, right? And the cancer and the sleep connection. There is a big cancer and sleep connection. If you are a man and you suffer from insomnia, you actually have twice the amount of a risk of developing cancer, prostate cancer, right? If you sleep less than 6 hours per night, you actually have a 50% increase of colorectal cancer. And then if you're postmenopausal and you sleep fewer hours and you have breast cancer, your breast cancer is more likely to become aggressive and it's more likely to recur. So there is definitely this sleep and cancer connection. And they found this out looking at night shift workers. So the IARC is a branch of the World Health Organization, and they actually classify night shift work to be a type of carcinogen, right? And especially like nurses who work the overnight shift, they found that with every 5 years of night shift work, the risk of breast cancer in women increased by over 3%, right? And male night shift workers actually have higher rates of prostate cancer, bowel cancer, lung, and bladder cancer. So a lot of this is difficult, right? If, that's the only shift you can work, that's the only shift you can work, but you want to really try and prioritize sleep. So why is sleep so important, right? If you have ever had the flu or if you've had COVID, right, all you want to do is just take a nap and sleep, right, and recover. And that's because while you're sleeping, that is when your bodies are recovering, and that is when your immune system is doing its job, right? So super, super important to get your sleep, especially this deep sleep. That is when your body is doing this healing. And the dendritic cell, that general cell that gives all the information to the other army cells and your natural killer cells, right? This is when it starts to activate. it's when your dendritic cells increase and activates and transmits those information to the critical T cells. And they did this experiment in healthy individuals, right? They took people who normally slept 7 hours a night, and just one night they reduced their sleep to 5 hours of sleep. And just that one night, it reduced their natural killer cell activity to 72%. So even one sleepless night can actually make a difference. So we definitely want to try and prioritize our sleep. So that's sleep, and then exercise. Exercise in cancer. Exercise is actually one of the most powerful things that you can do to boost your immune system and to prevent cancer, to improve your treatment outcomes of cancer, and also to avoid a recurrence of cancer. And, you have to start from where you are. If you're a person that, is undergoing treatment right now, and it's really hard to get in that exercise, you want just to try and start with just small 10-minute increments, right? The goal is about 150 minutes of moderate intensity exercise per week. So that's 30 minutes of exercise 5 times a week, right? But you start where you can, right? It doesn't have to be all at once. You can actually do them in 10-minute increments. So 3 10-minute increments through the day counts as 30 minutes of exercise. And it doesn't have to be going out and going for a jog or a run. It can just be a brisk walk, right? Moderate intensity means that you're too winded to sing while you're doing that activity, but you can still carry on a conversation. So if you go on a 10-minute walk with a friend and can carry on a conversation, that's moderate intensity exercise. So how does exercise influence cancer and your immune system, right? Well, when you're, in poor shape and untrained, then basically you're metabolically less healthy, and it usually encourages a low-grade inflammation in the body. So inflammation is also modulated by your immune system. So if you have a low-grade inflammation, then your immune system is basically distracted and unable to respond to the actual threat that it needs to address, right? While you're exercising, right, you undergo physical effects and endocrine effects, those are your hormone effects, and it actually improves the response and the activation of your immune cells. It makes your immune cells better able to infiltrate the actual tumor to do its work in attacking the tumor. And they found that if you're exercising, it actually improves your risk of your cancer. It keeps your cancer from spreading and from metastasizing. And then when you're trained, right, and you're metabolically active, your immune cells are really primed so they can actually go to where it needs to go when it needs to go. And also it improves your perfusion, it improves your circulation, so your immune cells are better able to reach those areas that it needs to. Also, exercising on a regular basis actually improves your side effect profile. So if you're undergoing chemotherapy right now, if you're undergoing radiation, you probably, don't feel well, and so it's going to be hard to exercise. But if you can even get in like a 10-minute walk just around the block, it actually helps to reduce those side effects. All right, so these exercise benefits have particularly been shown in breast cancer. And so women who exercise and who are regular exercisers, you actually have a 30 to 40% reduced risk of getting breast cancer, right? Women who continue to exercise after their diagnosis, you actually have a 64% lower mortality rate. So you're 64% less likely to die from your breast cancer than somebody who doesn't exercise. And then women who started exercising, they were never ever exercisers, right? And they decided that they were going to start exercising after being diagnosed. They actually had a 45% chance less of dying from their cancer than people who didn't exercise, right? And if you are a survivor, exercise actually reduces your breast cancer risk of recurrence by up to 50%, right? That's more than any drug that's on the market. So exercise not only helps to increase your immune system and reduce death and reduce recurrence of breast cancer, right? It is so good just for your mental health. Your whole outlook and the way that you feel improves drastically just by regular exercise, and your overall quality of life improves. So that's exercise. And then finally, stress. right? Stress. What does stress have to do with your immune function, right? How can something that's going on in your brain, your mental state, affect your immune system? But your brain is connected to your body, right? And stress and how you experience stress, it's all hormonal. So stress is chemical, and everything else in your body is also chemical, including your immune system. So stress isn't always a bad thing, right? If you're crossing the street and then like a car comes and is about to hit you, you want that stress response. You want your heart rate to go up. You want to be alert. So you want your adrenaline to go up, your heart rate to go up, your blood pressure, your sugar gets released into your bloodstream. So you have the energy to jump out of the way, right? So initially your immune function goes up a little bit, but most of the stress that we experience in our day-to-day life isn't this immediate stress that comes and goes, right? Most of us experience stress from our jobs or from our relationship or from money or other like worries that we have. And it's not just a one-time thing, right? We feel this chronic stress level. But the stress response is the same. The hormones that our body release to feel that stress is the same as that immediate stress. And when your stress is prolonged and turns chronic, your immune function also goes way, way down. So we know that stress decreases our immune function. It decreases the number of our T cells, our fighter cells, and their activation. It decreases the number of our natural killer cells and their activation, which is why it's so important to take care of our stress. Stress also increases our DNA damage. It makes our cells and our cell DNA much more fragile. So that means it's more likely to mutate. And it also impairs the repair mechanisms that we have, right? And because of that, it does increase our cancer risk. And in animal studies, they've actually shown that if you take an animal and you stress that animal out and they have cancer, it actually makes their cancers more aggressive. It increases their cancer progression and it increases their cancer metastasis. So this is why stress is super, super important to address as well. So like I said, stress is chemical, right? Our sympathetic fight or flight response when that car is starting to come towards us, right? We release epinephrine, norepinephrine, cortisol, and growth hormones. And so that initial response makes our heart rate rise, it makes our breathing faster, it makes our blood pressure faster, it floods our system with blood sugar. It also increases inflammation. But we don't want that to go on for a long time, right? Because that's no good for our bodies. So how do we counterbalance that? We counterbalance it with our parasympathetic or rest and digest mode, right? That will counteract our fight or flight mode. And that is governed by other hormones. It's governed by dopamine, oxytocin, serotonin, and endorphins. So these are our feel-good hormones, right? And when we release these things, our heart rate goes down. Our breathing returns to normal, our blood pressure, our blood sugar, and our inflammation reduces and goes back to normal. So how do we do this, right? There are ways of sort of hacking into our happiness hormones that we can do this mindfully, right, with stress reduction. So for example, dopamine, right? There are lots of unhealthy ways that we can increase our dopamine, right? Like scrolling on social media and getting all the likes that increases our dopamine. But rather than doing that, we can also do this in healthy ways. For example, listening to music, right? Just listening to music actually lowers our heart rate and our cortisol levels. It releases dopamine and it improves this overall level of happiness. And a global study showed that especially during this pandemic, music really helped people and played a big role in relieving stress during the pandemic. So that's dopamine. Oxytocin. Oxytocin is the love hormone. You release it by getting that sort of skin to skin contact, hugging your family, hugging your pets, right? Just petting your pets, it actually decreases our cortisol level, our adrenaline level, and increases this happiness oxytocin hormone. And they found like this research study done in Sweden looked for elderly people who were living by themselves. And if they were living with pets, their heart attack risk actually went down, their cardiovascular death, and all causes of mortality actually went down by 33% just by having pets. So pets may not be for everyone, but it just goes to show how oxytocin can have a positive impact. Serotonin. So serotonin is released by going out in nature, right? In Japan, we have this word shinrin-yoku, or forest bathing. And if you've ever walked into a forest, been around trees, you can just feel your blood pressure and your heart rate coming down, right? And that's your serotonin boosting and your cortisol and adrenaline going down. And it doesn't have to be a forest. Just going out into a park or standing under a tree, looking out into your lawn, like just being in nature, even in small ways, even looking at a photo of nature, or having, if you're in a hospital, having a hospital room that overlooks a window with, a tree outside, has actually shown to improve your healing, and actually has boosted your serotonin levels. So it decreases your stress and anxiety. It improves pain. It improves your memory and concentration. It actually increases empathy. And so it increases your connection with others. So being out in nature and actually increasing your serotonin levels strengthens your immune system. It's been shown that if you go out in nature, if you spend 3 days in nature and then take your blood levels of your cancer-fighting natural killer cells, your cancer-fighting NK cells actually increase. And this level of increase actually stays with you. We spent 3 days in nature for 30 days, for a whole month, your natural killer cell levels are elevated. So that's serotonin. And then finally, your endorphins, right? These are the painkiller hormones. When you run and you get that natural runner's high, that's your endorphins. And laughter. If you laugh, it actually releases endorphins. So they say laughter is the best medicine. And it doesn't have to be pure joy, laughter out of joy. It can be forced laughter from laughter yoga, like practicing laughter, and it can just be from watching comedy. They did a study with a bunch of cancer patients where they took half of these cancer patients and they took them out to watch stand-up comedy. And then they took another group of cancer patients and they took them to watch some sporting events. And they found that the group that went out and watched stand-up comedy and laughed, they actually increased the number of their natural killer cells, right? And the quality of life, their pain reduced, their mood improved, their depression, anger got better. So, laughter, it's a cheap, free way of increasing your endorphins and increasing your quality of life and increasing your immune system. So that's basically, ways to eat, sleep, move, and relax in order to boost your immune function and to help create an environment to fight cancer. So are there other ways to further increase your cancer-fighting immune cells? There are, right? So there's a new type of medicine now called regenerative medicine, and this is fighting your own illnesses using your own cells. We can actually take out, through a blood draw, your own immune cells and grow them in a lab and increase them by billions, and then retransfuse them back into your body, right? Such as your natural killer cells. We can actually create a cancer vaccine by growing out your dendritic cells and training them to target your specific cancer, right? And this creates long-lasting memory cells, right? Because it's a vaccine for long-term, remission. And because these are your own cells, your side effect profile is much, much lower than a lot of conventional medicine. So this is something that we do. Oh, let me go back. Okay, in our clinic, the Tokyo Cancer Clinic, this is some photos of our cell processing center where we have trained technicians that take your immune cells from a blood draw and they isolate out the cancer-fighting cells. We multiply it to the billions and then train them to target your specific cancer. And so this is what it looks like for a natural killer cell to kill a cancer cell. So this footage isn't my own, but this large cell right here is a cancer cell. And these little cells that are attacking it, those are natural killer cells. And you'll see as they're attacking the cancer cell, it's injecting them with certain substances to make them do this. Okay, this is apoptosis, right? Programmed cell death, and your natural killer cells will attack your cancer cell and inject them with these substances to make your cancer cells undergo self-destruction like that. Pretty fascinating stuff, right? Yep. Here we go. Trying to get to the next slide. Okay, here we go. So these are what natural killer cells do, right? This is a little experiment we performed in our lab, right? These are breast cancer cells in a petri dish, all right? And then we added natural killer cells that we grew out in our lab. And after just 5 hours of adding natural killer cells, you can see that these breast cancer cells just start to undergo apoptosis or cell death. So very cool stuff. Okay. And then the other therapy that we do is with the dendritic cell. Remember, these are the general cells that they're the ones who can recognize what is a cancer. And then it takes that information and transmits that to the immune cell army in order to target specifically your cancer cells, and it leaves your normal cells, your healthy cells alone. There is a dendritic cell vaccine type called Prevenge that's FDA approved in the United States, but this is only used for prostate cancer. And this is an example of a dendritic cell vaccine. We've actually made our dendritic cell vaccines through a patented process. It's patented in 12 countries, and it can target your own specific cancer, not just prostate. So how our immune system recognizes what is a cancer cell and what is not a cancer cell, right? This is a diagram of what the surface of a cancer cell looks like. And it's got these little peptides, right? These little markers on the surface of the cell. And you might have heard of some of these like CEA, HER2, CA125, PSA is also one of them. So our cancer cells have these markers on the surface of their cells. And that's how our immune system can recognize that this is a cancer cell. And not everybody has the same markers, right? So patient A and patient B, they both could have the same type of cancer. They both could have small cell lung cancer, for example, and they could be at the same stage. But when you do their blood draw and check their biomarkers, right, they'll have different biomarkers and different levels of their biomarkers. So if patient A's biomarkers has high CEA, high PSA, high New York SO1, right, we create their dendritic cell vaccine specific to their cancer. Whereas patient B might have high CA125, high HER2, high MF1. And so we create her dendritic cell out of her own cells with the targets that are specific to her cancer. So this is what a dendritic cell looks like. There are these funky little cells with these little arms, right? And that's how they recognize what a cancer antigen is. They take that in, and then they will go and transmit that information to your fighting T cells. So these are your fighting T cells, these little ones. And then in this corner here, you'll see the dendritic cell marching along, and it's extending its arms, its little tentacles out, and it's giving them that information right here. It's saying that these are the targets that you need to seek out and destroy. So very cool. Okay, so the protocol for what we do is basically, a patient will come to our office. They undergo a very simple blood draw. We check their tumor markers, so like what biomarkers are elevated, so we know what to target. And then we take 25 milliliters of blood. That's about 4 tubes of blood. And from those 4 tubes of blood, we can separate out their natural killer cells. So we take out their natural killer cells and we take them in the lab, and we increase them, expand them to the billions. And then 14 days later, 2 weeks later, they're ready to be administered through an IV. Right? From that exact same blood draw, from those 25 milliliters, we can separate out monocytes. And the reason why we separate monocytes and not dendritic cells are very, very rare in blood. Out of all of our immune cells, it's only about 0.4% of our immune cells are dendritic cells, right? The army cells. So we separate and set out the monocytes, and we proliferate, we make those monocytes expand to the billions, and then we transfer them and we turn them into dendritic cells. And then from there, we pulse these dendritic cells. We train them by interfacing them with your cancer antigen. So that would be your HER2 or your CEA or your PSA. So we pulse them with different cancer antigens specific to your cancer. And we try and do this with at least 4. And if you're eligible for other types of cancer antigens based on your biomarkers, we can actually add different antigens that are specific to your tumor. Also, if you have fresh tumor, right? Let's say you know that you're going in for a biopsy, and your surgeon will part with like a small amount of that tumor, we can extract the tumor antigens from your specific tumor and add them at the step, so that we're creating a cellular vaccine against your own tumor based on the biomarkers that you know that you have, that you want your immune cells to attack. And you can actually make it attack your specific tumor by feeding it the biopsy, the tumor, your actual tumor. So this also takes 14 days to create a mature cell vaccine. So at the end of 2 weeks, you would come in and get your natural killer cells through an IV, and then we would also inject you with your specific dendritic cell vaccine at the same time. So we do this and we repeat this 5 times, and that is considered 1 round of therapy. So the entire treatment for 1 round of therapy takes about 12 weeks, 10 to 12 weeks. So, and because they're your own cells, the side effects are very, very minimal, right? Some people will get a little bit of a redness or an itchiness where you got your vaccine, like most vaccines, and some people will get a little bit of a fever, and that's your immune response for the first 24 hours, and you can take paracetamol or Tylenol to reduce that fever. But that only occurs in about 10% of our patients. So that's basically our protocol for hybrid immunotherapy. So how effective is this? Right. So these are just some numbers that we got for about 5 years. And when you undergo the entire treatment of using the dendritic cell vaccine and the natural killer cell therapy together, generally, without treatment, obviously everyone tends to progress. But in 41% of cases, we were able to stop the disease in its tracks. Right. And so at the end of the 3 months, we reassess them. And if the cancer didn't get worse, but it didn't get better, then we consider that stable disease. Right. If their tumor shrinks by 30% or more, we consider that a partial response. And 25% of our patients actually had a partial response to this therapy. And in 7%, 7 to 10% maximum, generally, we found a complete response. And so a complete response is when their tumor was no longer visible on our CT scan. Okay. Unfortunately, 27% of patients do tend to progress in their disease. And this is all of the different cancers. We treat all types of different cancers, and it is all stages. So stage 1 through stage 4. Most of our patients are stage 3 or 4, and so they've tried other therapies already. And some of these patients, a lot of these patients are also concurrently undergoing either chemotherapy or radiotherapy as well. So, but it's unethical to, restrict them to one therapy or other. So, we try and work with whatever their current therapy is. So I'm just going to go through a few case studies that we've had. This is a 89-year-old lady who had a left-sided lung cancer, and she actually was treated for that with radiotherapy and surgery. And after that, she actually developed a right-sided lung metastasis. So you can see this is her PET scan, where it's brightly lit up is where the cancer cells are gobbling up that glucose. So because of her age, she did not want any sort of aggressive therapy afterwards when she got her second cancer lesion. So she decided to do the dendritic cell vaccine and natural killer cell therapy. And then 3 months later, after her treatment, you can see that her cancer cells have completely disappeared on her scans. So this is a 60-year-old lady. She actually had breast cancer. And so she had breast cancer, she had surgery, she had radiation and chemotherapy. And she was, without any evidence of disease for a number of years. But after a while, she actually presented with headaches. And when she got a CT scan and an MRI, they found multiple brain lesions like this. Right? These are all her breast cancer recurring in her brain. So we combined the dendritic cell vaccine and natural killer cell therapy, and she also received whole brain radiation. And then with these two treatments combined, she actually, you can see after her treatment, these lesions have all cleaned up. And then finally, this is a gentleman with gastric cancer, stomach cancer. I'm sorry if these photos are a little bit graphic. This is a view of an endoscopy. So when you look in through a camera at the stomach from the inside, you can see this very, very large, ugly looking tumor. On this CAT scan, you can see this is the stomach, and this whole lining of the stomach, this whole area here is just a very thickened area of gastric cancer. So this patient, was doing some chemotherapy, but and he wanted surgery, but his surgeon said, I'm sorry, this tumor is just too big. There's no benefit in doing surgery at this point. So he opted to do our dendritic cell vaccine and natural killer cell hybrid therapy. And after treatment, actually, this worked so well that you can see that this big, large cancer shrunk down, and all that was left was a small area here. And on the cancer cell, on the CT scan as well, where this whole area was filled up with tumor, now this is shrunk and you just have this small area. So at this point, his surgeon said, okay, well, we can actually do surgery now. And so they did surgery. They were able to take out the cancer, and this patient did very well. So those are just some case studies that we had. So who is this treatment a good fit for, right? Obviously, because it does use your own cells, right? The better your general health, if you're able to take in adequate nutrition to strengthen your immune system, it's a really good fit for you and tends to work better for in those patients. So if you're able to walk, do some self-care, carry out light tasks, we have used this treatment in patients who are, pretty much bedbound, who are living in Japan. But even though it does improve their state and improves their quality of life, if you want the best benefit for it, it's, really good with patients who actually have a good baseline level of activity. So if you're traveling to Japan, obviously you have to be fit to travel, right? If you are having trouble breathing, or if you have a lot of fluid like in your lungs, it may not be safe to fly. So those are some things. And if you are coming from abroad, I think if you've been introduced to our therapy through certain medical companies, medical tourism companies, discuss with them, and they help arrange with us whether or not you are a good candidate, whether you're fit to travel. And so, they also help us out in trying to determine if this is a good treatment for you. Who can't get this treatment, right? Because we take the immune cells and grow them out in the lab, like any viruses that live inside these immune cells, by increasing those cells, you're also increasing your viral load. So if you test positive for HIV or another virus called HTLV, then you cannot get this treatment, because by increasing your immune cells, you're also increasing the viral load. Right? You cannot get this treatment in Japan if you're currently on a checkpoint inhibitor anti-cancer drug. So these are drugs that encourage your immune cells to attack the cancer our cancer cells are pretty clever. They have these sort of stoppers to try and keep the immune cells from attacking. And what these checkpoint inhibitor drugs do, they're also known as Keytruda, Yarvoy, Opdivo. These drugs, they try and cover up those barriers for the immune cells to come and target it. So the fear is, and right now the Japanese government is saying, don't combine these two treatments, because what happens is when you hide these barriers and you're increasing how much your immune system is functioning against it, the fear is that you will have an overactive immune system and you might have bad side effects from that. So that's why in Japan right now, you're not supposed to do the checkpoint inhibitors with the anti-cancer drug. And the way we go about it is, if you need to go on a break from the checkpoint inhibitor drug, I mean, if this is working really well for you, then I would by all means stay on that. But sometimes if you're not a responder to this drug, or if you're taking a break from this drug. If you take a break from it and wait 3 weeks so that the drug washes out of your system, then you can take our cellular immune therapy. And then after you're done, wait another 3 weeks before you go back on the checkpoint inhibitor anti-cancer drug. So that's how we recommend going about this. And then finally, you cannot get this treatment if you're younger than 5 years old. And the reason for this is because when you take out a large, volume of blood, 25 milliliters can be quite a lot for a small person. Then it's, a pretty heavy burden on the body. So if you're younger than 5 years old, you cannot get this treatment. All right. Can it be combined with other treatments such as chemotherapy and radiation? Absolutely. We encourage you to explore all your options. We want what is best for you and what works for you and your body. And we try to work around your treatment schedules. If you are undergoing chemotherapy, we'll try and coordinate our scheduling and your therapies in association with that. Can immunotherapy be used to prevent recurrence? Absolutely. And this is probably where it is most helpful, even though it's helpful through any stage of your cancer. Because like we talked about earlier in this talk, by the time a tumor is visualized on a CAT scan, you already have 100 million tumor cells. So, if you go, and check your biomarkers with your oncologist every 3 months or 6 months, and you notice that these biomarkers are starting to go up, but you do your scans and like, well, we don't see the tumor, but your biomarkers are starting to go up. There's a high suspicion that your cancers are actually starting to expand and grow. They're just not at the level where you can see it on CAT scan yet. So this is actually the perfect time, because your oncologist, their hands are tied. They can't do surgery. They can't, start you on chemotherapy or do a treatment that is very hard on your body if they don't see the tumor, right? But this is the perfect time to get immunotherapy, because your immune cells work best on the small tumors, right? To get rid of it before they start to grow out of control. So that is like the perfect timing. And people who are who know they have the BRCA gene, or they know that they have cancer that runs in their families, a lot of them will do this treatment just as part of prevention as well. Okay, can this treatment be done in other countries? At the moment, this therapy is only done in Japan. And the reason for that is because a lot of countries have regulations on like bringing in blood samples from overseas into Japan, and also have regulations on bringing in biological specimens from Japan into their countries. So the other thing is, because these are live cells, from the time you draw your blood to the time it gets to our lab, and then from the time your therapy is done and to getting it into your body, it really has to be done within 24 hours to have the best effect. So currently we are only able to do this treatment in Japan. I think there are a number of people on this call that help patients come to us to get this therapy. So I would contact them in order to how to do this logistically. And, what is my investment, right? What does it cost to get this treatment? This is the price that we list on our website, and it is just for the treatment natural killer cell and dendritic cell vaccines for 1 round of therapy. If you are coming in through these other partners that we have that help bring patients over to Japan, you will have to talk to them about how much it costs, because they also help with visas if needed. They also help with translation services if needed, and they do all the they create the appointments for you, and they have other services. So you'll have to defer to them for the prices. But if you're already in Japan and you're coming directly to us, the price is 2,705,000 yen, which roughly translates to about 19,000 US dollars. Right now, it used to be almost 100 yen to $1, but right now the yen is very weak. So it's the ideal time if you're in the United States and you want to come here for therapy, because the yen is very cheap right now. So that's basically it for my talk. We do offer a one-on-one consultation with our oncologist at the Tokyo Cancer Center, at the Tokyo Cancer Clinic. You can go to our website, tokyocancerclinic.jp, or you can email me directly at abe@tokyocancerclinic.jp, or email me to the email address that you got the link for this webinar from. And we do, if you are in Japan, we do offer a free in-person immunotherapy consultation. So, bring in your CAT scans, bring in your blood work. If you're doing this by Zoom, we can do this by Zoom. We do charge a nominal fee, 11,000 yen for an hour consultation. And if you actually come to Japan and get this therapy with us, then we deduct that from your overall cost. If you're more interested in the cancer coaching and the lifestyle aspect of it, I do provide one-on-one cancer coaching with you. A lot of us know what we're supposed to do. We know that we're supposed to exercise and eat correctly and not drink and all that stuff, but it's really hard to stay on track. So I help individuals stay on track, make sure that for their lifestyle, they are able to follow the optimal sort of lifestyle to boost your immune system and help work with all of this. So thank you so much for your attention. Basically for lifestyle medicine and coaching, you can also find me directly on my website, drminako.com. I post almost every day on social media. So I'm on Facebook, Instagram, LinkedIn, and I have a bunch of YouTube videos on lifestyle. You can find me at Dr. Minako. If you're interested in the immunotherapy portion of it, you can go directly to our website, tokyocancerclinic.jp, and we also do have Facebook and Instagram at Tokyo Cancer Clinic.